Hey, hello guys, this is Shubhabrato and welcome back to my channel circuiTician. I hope that you have enjoyed the last two videos of our IoT based RFID home security system. In the first video, I have shown you the system block diagram, the circuit diagram and the PCB designs, and in the second part, I have shown you the assembly and the installation process. So in this last part, I will show you the demo of the system, the coding and the Android application. So don't skip the video, watch till the end. Let's get started.
Initiating Sequro, your fortress of digital security. The device is connected with the provided Wi-Fi network. Starting in online mode. Card reading mode. Gate lock is open. Open the gate after the long beep.
Now I have opened the gate using the touch switch, and after closing the gate, the lock will be automatically closed. So here is our Android application. After opening this application, you have to click on I am agree with terms and conditions. Then you have to click on sign up with Google. So from here you have to choose one of your Google account. So after that it will take some time. Here the name and email ID will be automatically fetched from your Google account, and here you have to put your 10-digit mobile number. So here you have to put the mobile number without the country code. That is, in my case, that is +91. So I am removing the country code, otherwise it will show error. So click on save. So your account is created. Now you have to click on this plus button to add your device. Now I will add my Sequro device in my mobile application by scanning the QR code. Now I am going to control the gate lock using my mobile application.
Gate lock is open. Open the gate after the long beep. Gate lock is open. Open the gate after the long beep.
You must have seen that when I am adding the Sequro device on my mobile application, I have scanned a QR code. So what is that QR code, why it needed, and from where you will get that QR code? Basically, that QR code consists the information of the Firebase database path where the device or the ESP32 is sending the data, or from where the ESP32 will fetch the data. So we have to scan that QR code to inform our app the exact path from where the app have to fetch the data or send the data. So the app's data center and the ESP32's data center path should be same, so our app and device can pair together. So to generate that QR code, you have to download one app called QR Maker. This app is also made by me, so you will get that app link in the description below. So you have to download and open that app. You need an active internet connection on your mobile to run this app. So first you have to click on this generate QR code for Sequro, this button. Then you have to enter your device ID, which is written on the code. Basically, you can find a variable named dname in the code, and you have to give your device ID there. And like if you are putting your device ID like dv1, so here you can put your device ID, and your device ID should be of 3 characters, like I'm giving here dv1. Then you have to click on this button, click to generate. So here you can get this QR code. Now you can screenshot it and print it in a paper, or you can directly scan from this mobile application. Let's add a RFID card.
Card adding mode. Open your Sequro mobile application and go to Add Card section. Then hold the new card near the RFID reader. Card added successfully. Now toggle the switch to put the device into reading mode. Card reading mode. Access granted. Gate lock is opening. Open the gate after the lock beep.
Let's add a FOB tag.
Card added successfully. Now toggle the switch to put the device into reading mode. Card reading mode.
Now I am going to revoke the card access which I have just added.
Access granted. Gate lock is opening. Open the gate after the lock beep. Access denied. Access granted. Gate lock is opening. Open the gate after the lock beep.
Now I am going to add a card which is previously added in the system. Now let's see what happens.
Card adding mode. Open your Sequro mobile application and go to Add Card section. Then hold the new card near the RFID reader. This card already exists in this system. Access granted.
Now here you can see the last entry. You can also see all the access logs here.
Hey, hello everyone. This is Priyobrata and I'm going to explain the code for the IoT-RFID lock system. I hope you are enjoying the last two videos where we have shown the installation and demonstration of the devices and the system block diagram of the IoT-based RFID lock system. So today in this video I am going to explain the code for this system. So as you can see, here are 7 code files including .ino files, 1 INO file and 6 to 7 .h files, each for different devices. Like df.h is for df player mini, NTP is for time server, RFID for RFID reader. So I am not going to explain each and every file to you. I am just going to explain the flowchart or the algorithm, how the code works as simple as I can. So to understand the code, first we have to know what are the devices there are in the system. First is the RFID reader, by which we are scanning the RFID cards, and second is servo-based gate lock system, which we have shown you in the last video. Next we have the open and close position limit switch, by which we can understand if the gate lock mechanism is open or closed. And fourth is magnetic reed switch for gate alignment, by which we can understand the gate is in open position or closed position to actuate this gate lock mechanism. 5 is the notification system, which is a speaker with a DF player mini. So when some activity is happening, so there will be a voice notification also. And then there is ESP32 with internet connectivity. So this is also IoT based. So we are using the ESP32 microcontroller. And the last is touch switch box, by which we can control the gate lock mechanism also. Now let's look at the flowchart of the code. So after starting, the code is looking for new RFID card. If there is no card, then it is continuously looking in the void loop. If there is any new card, if it is yes, then it checks for the card has access or it doesn't have access. If the card have access, then it checks if the gate is closed or not. If the gate is closed, then it opens the gate lock mechanism to open the gate. And one more thing, if the card doesn't have access, then it will return to the first step. It will be looking for new card. It means the first step will run continuously in the void loop. Now, how in this step, how we are checking the card access? The card access with the card number is stored in EEPROM memory of the ESP32. So we are checking the card access from the EEPROM memory. If it has access, then it checks for if the gate is closed or not. If the gate is closed, then it opens the lock by the gate lock mechanism, which we have shown you in the previous video, servo-based gate lock mechanism. You can also use the solenoid-based gate lock system. It will also work. And then next, after opening the gate, it sends the card number and date time to the Firebase. So here we are using Firebase as a cloud database. So when the gate lock mechanism is open, every time it sends the card number and date time to the Firebase, so that it can keep a record when the gate is accessed as a log. So the whole log is there in the Firebase database. After sending the data in the Firebase cloud, it checks for if the gate is aligned to the closed position. If the gate is aligned to the closed position, then it close the lock. The servo-based lock mechanism that you have seen in the previous video, it actuates that if the gate is in closed position, otherwise the lock will not work. This is the flowchart of the code. All the code files link will be in the description. You will get it from there. And if you have any questions regarding the code, then you can ask in the comment section also. So this is basically it. This is how the code works.
So let's have a look on our Firebase database. So here you can see a project bucket called DVS. It means devices, and underneath it you can find another project bucket that is called S1Q. Basically, in our mobile application you can add up to 4 devices, so all the devices will be saved under this DVS project bucket. And as my device name or D name is called S1Q, so all the data from that device will be saved under this S1Q project bucket. So if you are adding more than one device in your mobile application, so put the device name different. So under this S1Q, all my data will be saved. And now I will try to show you one data here. Basically, under this status tag, you will find a tag called solve. Basically, this is the tag which is responsible for opening and closing the gate. Now I will try to open the gate from my mobile, and here the data will be changed. So here you can see the data 1, and most probably you have heard the sound from the outside that the gate lock is opening. Now I will close the gate lock. So it became 0. So after uploading the code into ESP32 and setting up the device with your mobile application, your database should look like this. As we are done with the coding, now we will give a look into the Android app. So for that, you have to open codular.io, and there you have to import project. As I have made various Android application, so there are the application, but your screen will be empty, and here you have to click import project. Then you can find a .aia file in the description. You have to download that file and you have to upload this file here. So click on choose file, then select the file. The file name is Sequro.aia with the extension AIA. Open it. Now click on import. It will take some time to import the file into this page. Wait for that time. Here, as you can see, the file is imported. Now click on it to open the AIA file. So here you can see the file is open. Now you have to change some certain things. Here in our Codular platform, there is 2 sections. One is designer and another one is blocks. So we don't have to change anything in the block section because the block section is very large. You cannot edit here any one block because it may crash the app. So here you can see how much block I have here. So total we have almost 2,300 blocks. So you don't need to change here anything. You just change the Firebase API key and URL in the designer section. So here are some Firebase objects like app details, card ACC, status, entry list, all the Firebase object. Here you have to only change the Firebase token and the Firebase URL. If you don't know from where you have to get the token, basically token is the API key. You have to get the API key and the URL. You can watch my previous video, like I have made a video on ESP32 and Firebase. There you can know that how to get this Firebase token and the URL. Link is given in the description, as well as you can get the link in the I button. So here you only have to change this Firebase objects token and the URL. You don't have to change anything in this application, either this app may crash. So after changing all these details, you have to click on export, then Android app. It will create the android.apk file which you can install in your Android mobile. So it starts to building the .apk file. So here is the progress bar. It will take some time. Wait for that time. Here you can see that our .apk file is ready. You can scan this QR code in your mobile to download the APK file, or you can directly click on this download APK button to download the file in your desktop system. I hope you guys love this video. Then make sure you hit the like button, because we put in a lot of effort to make this project as well as making these 3 videos. So give a thumbs up to this video and share all the 3 videos with your friends and technical community. And if you are new to this channel or seeing me for the first time, you can subscribe to my channel because it's free for you, but it will help me a lot. And the link of the project details you can find in the description. And if you want to support our effort, then you can buy me a coffee. That's link also available in the description below. And the most important thing, be creative.